5.8. So we've talked about graphing exponentials, okay? And we know that this whole unit has to do with exponentials and logarithms. So we're going to end this unit with graphing logarithms, okay? First thing we start off with, graphing logs without a calculator, okay? We get to use a calculator on everything. So I'm really not worried that you know how to do this, but I do want to show you that it is possible to do this without a calculator. Okay, so if that were to happen, we need to put it in y equals form. So for instance, we're going to start off with this equation right here, f of x equals log base 2 of x. Okay, so if I were to put that in y equals, I just change f of x to a y. So y equals log base 2 of x. Then I use my knowledge of logarithms to make this into an exponential function. My base would be 2, my exponent would be y equals x, okay? I would then want to make a t-chart, okay? So 2 to the y power equals x. In order to make this t-chart, I would actually need to plug in values for y, okay? Because that's how I'd be able to do this without a calculator. So I could do like -2, -1, 0, 1, 2, or whatever numbers I choose. And then 2 to the -2nd power. Think about in your head what that would be. It'd be the same thing as 1 over 2 to the 2nd, which would be 1 over 4, or 0.25, okay? 1 over 2 to the 1st would be just 1/2. 2 to the 0 power would be 2 to the 1st, 2 squared, 4, okay? So these would be my points, so I'm going to try to plot these the best I can. Okay, and we'll see that these types of graphs are going to look very similar to the exponentials, but it kind of looks like I took that exponential graph and I tilted it. Would you agree? Yeah. So if I take this whole page and I do this, isn't that what we just learned how to graph? But now it's this way? Whoa, how weird. It is weird. Okay, do you notice how there's no negative x values on this? Yep. Yeah, why do we think that that happens? What do we know about logs and negatives?
They don't work.
They don't go together, do they? So if I try to take a log of a negative number, we call that undefined, incorrect. Okay, I'll take it. You're right. Undefined, incorrect, whatever you want to call it, Tate. Okay, so why can we not get negative values? Because negative logs are undefined. Duh. Cool. So that's what we're graphing today. Fun stuff, okay? Except for, let's throw out that not using a calculator and let's start using them, okay? Because I want you to be able to do these and I want you to use that calculator to your advantage. So, we start off with this first one. Log base 1/3 of x. All right, good deal. So, when we made tables for the last section, so for exponentials, we took that exponent, right, and we set it equal to 0. Remember, and that was our middle point, okay? So for these types of graphs, I want you to find the a value of the logarithm, which in this case is just x, and set that equal to 0. What is x equal? What would that be? Just 0, right? Okay, so x equals 0. And that's going to be the starting point of my table. But here's the deal. I would not need to put that 0 right here and then do negative values to the left, positive values to the right, would I? If I can't go negative. So I'm actually just going to start with the 0. Okay? And I know that since that value makes that exponent, or makes, not the exponent, sorry, makes that a value 0, that this is actually going to be my asymptote. Okay, so whatever that a value is set equal to 0 is going to be your asymptote, except for It's not going to be a horizontal asymptote, is it? It's going to be vertical. Good. So this is going to be the equation x equals 0, and we are not going to have a horizontal asymptote, okay? Just a vertical one. So this is going to look just like this. Okay? And again, that 0 point, since it's on the asymptote, is undefined. So now I just need some points that are bigger, okay? Bigger than 0.
49.
1, 2, 3, 4, and you want to do 49?
Yeah.
Okay, that's going to go off of our graph because our graph doesn't go to 49, but we could do like 10 if you want to do 10. Okay, you just need 5 numbers that are bigger, okay? You can do 4 if you can see the general shape with that, but sometimes 5 just makes it a little better, okay? So, how do we do this then? How do we type these into a calculator? Well, we know that we can type in stuff to our calculator by just doing log of A divided by log of B, right?
Yeah.
Yep. So in your calculator for the first one, you're going to want to type log of 1, close those parentheses, divided by log of, what's the base? 1/3. And that's going to give you your first y value. 0. Cool. Now hit the back button. Go change that 1 to a 2. Negative 0.6. Okay. 3. Negative 1. 4. Negative 1.3. And 10. Negative what?
Yeah.
Negative 2.1. Okay, cool. So now we go and we plot these numbers. We know the first one's undefined, so we don't need to plot that. Plot 1, 0, 2, negative 0.6. Just try your best on those decimal ones. And all the way to 10, negative 2.1. Okay. So we now have points that look like this. Would you agree? Okay, here's how you do this, okay? We can see that this line is going outwards, right? But this part of my line is going to go towards that asymptote. It's never going to touch it, right? But it's going to get super darn close. And it's going to keep going forever. You with me? Cool. Okay. So, since we flipped this on its side, a couple of different things are going to change, but they're going to be super similar to the other way, or to the exponential way, so make sure you don't get these confused. Domain is no longer negative infinity to positive infinity, because this is not going left forever and right forever, is it? No. Where is it starting at? 0, and it's going to infinity. So that's kind of like the range on the exponential, right? Maybe. What do you think the range is here from bottom to top? You think this is going down forever and up forever?
Yes.
I would agree. Yep, so they're switched. Makes sense. Okay. Limits, we always got to pay attention to these. We still have x going left and x going right forever, okay? For our bounds here. So as x goes left, what is y doing? Going up forever. Okay? And then as x goes to the right, what's y doing? Decreasing. It's going down forever. So negative infinity. Cool. Left to right, follow those arrows. Is this an increasing or a decreasing one? Decreasing, so it's not increasing. For decreasing, we just need to rewrite the domain, so 0 to infinity, good. X-intercept, do I cross the x-axis? Yep, is it in my table? Looks like it is, right there. 1, 0. And then what about the y-axis? None, right? Because it's the asymptote, so we can't go through that. Right? Don't touch my asymptote. Okay. Questions on this? That's what we're doing today, folks. Okay, it's going to get a little harder, but not much. Okay, log transformations. Just know that we can have transformations with these. We'll get back into graphing, but we're going to look at this first, okay? Again, when we start our table, we set this a value equal to 0, okay? This is also just your h, so if there's a number in there with, or like x minus 1, x plus 2, that's that left and right shift, okay? The h shift, so we'll call this h, okay? Because again, it tells us where we're starting, it tells us where that asymptote is. And then this is still going to be a k shift, so if there's a plus 1, that means we're going up 1, right? If it was minus 7, that would mean we're going down 7. Okay, it's still going to shift these graphs. And then, honestly, that first circle, I don't even really know why it's circled, but just know that that's where your base is right here. Okay, so pay attention to what your base is, because that's going to totally change your table if you type in the wrong one. So know that this is your base. Okay? Cool. And then domain is always going to be, you got to watch out for your asymptote, right? So it's going to be, if it was reflected, for instance, it would be this, but we probably won't see that very much. But normally it's just going to be your asymptote to infinity, okay? And then range is always going to be negative infinity, positive infinity, no matter what. Okay. All right. So, I'm going to help you start this one. First things first. If I want to start this table, how do I start it? Not yet. X minus 1 equals 0. What does x equal? 1. So that's my undefined point, or my, starts with an A. Up, vertical asymptote. Okay, so would that be x equals 1 or y equals 1? X, good. We can go ahead and draw that. Okay. I'm going to let you finish this one, but first let's set up how we would type a number into a calculator. Well, first let's set up what other numbers we want to plug in. So after 1, what should we do? 2, 3, 4, 5. If you want to do a bigger one, you can, but you can do 6 if you want. When you go to type this in, you're going to type in log, then what? 2 minus 1 in parentheses, right? Because again, we're plugging it into this. So it's x minus 1, so we got to do 2 minus 1 divided by log of what? The base, 4. So you should type it in just like that. So I'm going to have you go ahead, fill in your table, plot your points, and see how far you can get on those blanks. All right, let's keep going through this one. When you plugged in 2, what number did you get for y? What about 3? 0.5? 4? 0.79? 5? 1? 6? 1.16, perfect. So now we go and we plot these points. Anybody do anything bigger than 6? No, everybody picked these. You did 8? What'd you get for 8? 1.4, okay. If you do 9, it's 1.5. How cool. So this thing is going to do that, right? It's not super steep, okay? And then it's also going to get close to the asymptote and go down, right? That looks a little different than the other one, doesn't it?
Yeah, it looks like it's increasing.
It's increasing. Huh. What do you think made it do that?
Probably the base.
Yeah, the base is bigger, right?
Yeah, probably.
So you think that there's a correlation there? How we talked about on the exponentials, if the base was bigger than 1, it grew, right? And if it was smaller than 1, what did it do? Decreased. And so now you're saying that if the base is bigger than 1, it's increasing?
Sure.
And if it's smaller than 1, it decreased. How weird. Okay. Domain, what do we put? 1 to infinity. Range? Perfect. Was there a horizontal asymptote? Heck no. Okay, limit. So your left limit. So as x goes to the left, what's y going to do? What'd you say? It's going down to, not to 1, but to negative infinity. Okay, and then as x goes to the right, what's y doing? Infinity. Okay, we said this one was increasing, so what do I need to write on the increasing blank? The domain. Decreasing. NA or none. X-intercept. 2, 0. Do I have a y-intercept? No, why not? Yep, my asymptote is 1. Cannot cross it. Good deal. Questions on that one? All right, let's keep going. Ooh, what's different about this one? A number in front, right? Okay, do you think that's going to really change much about this? Not much, okay? But let me ask you something. If I were to rewrite this like this, log base 2 of x plus 3, and then I put that plus 4 at the end, is that the same thing? Yeah, it is. And what's that plus 4 at the end mean to do? It'd be a shift we talked about. Go back to the last page. What'd you say? Up 4, right? It's a K shift. Okay, so sometimes they'll try to trick you and they'll put that 4 at the front. It's not going to change anything. You're still going to have the same table. Okay, your graph's still going to look the same. But just know that that is your vertical shift. Okay, so we'll go ahead. We'll start our chart. First point, or how do I get this started? X plus 3 equals 0. What does x equal? And negative 3 is going to be my vertical asymptote. Good. What are we going to plug in after negative 3? Negative 2, negative 1, 0, 1. Do something bigger than 1. 4. Okay. All right, I want you to go ahead and plug those in. Make sure that when you are typing them in, you close the parenthesis before you add the 4. Or if you do the 4 in the front, that's fine, okay? Either way, you're going to get the same answer. So you can work with somebody around you. Go ahead and finish this one up. Okay, let's go ahead and plug in these values. So again, be careful typing these into your calculator, but if you were to type these in, you kind of have two options. You can do 4 plus, and then type log, parenthesis, type in your negative 2, plus 3, close parenthesis, divided by log of 2, right? Our base? Okay. You could also put the plus 4 on the back too, okay? Just make sure you close that parenthesis before you do it. Either way you do it, for negative 2, what should you get? What? 4. For negative 1? For 0? For 1? And for 4? Huh?
I didn't do 4.
You didn't do 4, you did 2. Anybody do 4? 6.3. Cool. Okay. So we draw our asymptote. Highlighter.
I got 6.3 for 2.
You got 6.3 for 2? You might be right. All right, either way you do it, it should look something like this. Okay? Domain is going to be what? The range? Negative infinity, positive infinity. 6.8 for 4? Okay. So it should be up here. All right. So one thing too, I want to real quick, I made a quick little mistake and it only changes our approach values. Okay, so typically we always do negative infinity, positive infinity right here because pretty much everything we've seen, the domain's been that, right? However, our domain is what right now? Negative 3 infinity. So this first one, instead of it being negative infinity, it actually needs to be a negative 3. So I apologize for that. But yeah, it needs to be your domain. So your left limit, right limit. Okay? So now as we look, so still, I mean, it means the same thing. As x goes to the left and approaches negative 3, what's y doing? It's going down, right? Negative infinity, good. And then as x approaches infinity on the right, y is going to infinity. It's increasing, good deal. Increasing or decreasing? Increasing, what'd you write there? Domain. None on decreasing. X-intercept. Ooh. There is one. Do we know where? Is it in our table? No. How would we mathematically find an x-intercept? Plug in 0 for f of x or y, okay? So, if you remember, when this happened with our exponentials, we had to set up a logarithm to solve it. Well, if this is a logarithm, what do you think I'm going to have to set up to solve it? An exponential, because again, we're inversing all of this. So, is the log on a side by itself? No. What's over there? The 4, what do I need to do with it? Minus it, subtract it, good. So negative 4 equals log base 2 of x plus 3. We're ready to set up an exponential. What's the base? 2 to what power? Equals what? X plus 3. If you can't set that up by now, okay, if that's confusing for you, if you need notes to do that, you need to practice those. You've got to be able to convert between logarithms and exponentials, okay? Now we just solve it. So what is 2 to the negative 4th? 0.0625 equals x plus 3. And now we just need to subtract 3. What is 0.0625 minus 3? Okay, we'll just call it negative 2.9 comma 0. That is my x-intercept. And if I go back up here and I look and I try to plot negative 2.9, it's going to be close to this asymptote. So yeah, it looks like my graph's going through that. So I did that right. Good job, Mrs. Bellman. Thank you.
Good job.
Thank you. Y-intercept. Yep, that one's in my table. 0.5.6. Good job. You guys did good too. There are a lot. We're not going to do all of them. Okay. We might do all of them because they're really not going to take that long. Okay. I want you to, what time is it? Okay, we got plenty of time. Okay, I want you to go ahead and just get used to graphing these. There's no blanks on these ones. You don't have to fill in all the other stuff, okay? You just need to graph both of these because I want to be able to tell what does this 4 in front of that log that's being multiplied, what does that do to my graph, okay? So go ahead and plot example 1 and example 2. It won't take you very long. You just got to set up a T-chart and plot points. And then answer that question, what does an A value do to your graph? Back, okay, cool. So, XY table. Where'd you start? 1, that was your asymptote? Yes, ma'am. Great manners. What numbers did you pick? 2, 3, 4, 5, 6, and what'd you get? What was 5? 3 and 3.1. Cool. Everybody agree with Lydia?
Yeah.
So, you got something that looked like this, right? Everybody with me? Yeah? Heads nodding? Okay. So then, for example 2, what was your asymptote? 3. And what did you plug in? 4, 5, 6, 7. What'd you get for 4? 5. 4. 6.3. 8. Okay, I would agree with that. If you didn't get those numbers, okay, here's how you type this in. 4 log parentheses 4 minus 3 divided by log 2. Okay, you only have to type that 4 in at the front. You don't have to do anything else. It will automatically multiply it. Anybody not get that? Cool. All right, so we plot these points. Okay, what did this do? What did that 4 do? Stretched it. Okay, and we know that since it's bigger than 1, it's a vertical stretch. So it made it a lot steeper, right? Okay, questions? Cool. Pretty freaking easy? Good. Okay, we have natural logs left. What time is it? All right, we'll go ahead and get started. It helps to rewrite the natural log base in log-based form. So if we have a base for a natural log, what is it? Or when we have a base? E, right? So e to the x equals y here. So if we weren't using a calculator, okay, or if we wanted to go backwards, we could go ahead and do this, okay? Plug in the y values that we need. I set that up wrong. It should be e, sorry. Whoops, e to the y equals x. Yeah, okay. Because again, this is our base. Our base is e for natural log, so e to the y equals x. Was not paying attention. Okay, so that's why we would go backwards on this. So e to the 0 would be, anything to the 0 power is 1. E to the first is going to be 2.718. We'll just call it 2.7. E squared, if I wasn't using a calculator, could I do 2.7 times 2.7 by hand? I could, but I don't want to, so somebody put it in your calculator and tell me what you get. 7.4, cool, okay? So again, if I were not using a calculator, this is how I would do this. But we do get to use calculators, which means that we are about to learn it that way.
I got 7.3.
7.3.
Well, you put 7.4.
7.3
7.38, which rounds to 7.4. Same thing. Okay. You guys good? Yeah? Okay. So it's going to look like this. Doesn't that look like what we just graphed? Yeah, it just has a base of 2.718, right?
Yes.
That's what this means.
Nice.
Nice. Okay. And my asymptote would be 0. Because again, we set that a value equal to 0, x equals 0 is 0. So it would be right there. So we're going to do these. These are super easy. My a value, again, is just what's with the natural log, and if there's anything in parentheses. But in this case, it's just x, right? So what makes x 0? 0. So that's my undefined point, or my asymptote. These are really easy to plug into the calculator. So same deal, I pick 1, 2, we'll just do 1, 2, 3, 4. If I type these in, -3 natural log of 1, close parentheses, plus 2. 2. Change that 1 to a 2. -0.08. -1.3. Okay, cool. So it's going to look like this when we graph it. Any questions on that? No? Do we need to do another one?
No.
Would we be able to answer questions on that?
Yes, we can.
Yeah? Okay, cool. We're done for the day.